AI development tools and infrastructure. The local first movement in AI tooling continues gaining momentum as Anything LLM releases an on-device meeting assistant that directly challenges the SaaS dominance of tools like Otter.ai and Fireflies. The new meeting assistant handles transcription with speaker identification, multi-language support, and custom summary templates, all powered entirely by local models. The performance numbers are genuinely impressive. A 3-hour audio file processes in just 3 minutes 26 seconds on an M4 Pro MacBook, or 3 minutes 10 seconds on an NVIDIA 4070. Even budget hardware manages the same workload in under 11 minutes without becoming unusable for other tasks. The technical stack reveals interesting engineering decisions. The team settled on NVIDIA's Parakeet 0.6B v3 for transcription rather than the more common Whisper, primarily because accurate word-level timestamps are crucial for speaker diarization, something Whisper apparently handles poorly. The system integrates with Model Context Protocol, MCP, for post-meeting agentic actions, meaning your local AI can automatically trigger workflows after transcribing. The assistant operates passively, never joining calls directly, which means it works with any meeting platform, Zoom, Slack, Teams, or even arbitrary media files like podcasts. For those who prefer brain dumping over structured note-taking, you can record yourself rambling and let a custom template reorganize your thoughts. Token efficiency remains a persistent concern for local model users, and a new serialization format called SONA claims to reduce context window consumption by 30 to 40% compared to JSON. The format uses type-indicating symbols like true for booleans and number 42 for integers, theoretically preventing type hallucinations during tool calls. Community reception has been skeptical, with valid points that LLMs are extensively trained on JSON and understand it well. Plus, any custom format only matters if it's actually used by downstream applications. The ecosystem includes Rust and Python parsers, WASM for edge deployment, and a VS Code extension, though the GitHub link was initially broken, undermining confidence somewhat. The Unsloth team delivered embedding fine-tuning support with their characteristic efficiency focus, achieving 1.8 to 3.3x speedups with 20% less VRAM compared to Flash Attention 2 setups. Most configurations need only 3 GB VRAM for 4-bit QLoRa or 6 GB for 16-bit LoRa. The practical applications are significant. Fine-tuning embedding models aligns vector representations to domain-specific similarity notions, improving RAG retrieval, clustering, and recommendations on proprietary data. Support covers modern BERT, Qwen embedding, embedding Gemma, and other popular architectures, with deployment options spanning transformers, LangChain, Ollama, VLM, and Llamat CPP. Developer tooling continues proliferating. A new TDD canvas for VS Code called integrates with Claude Code to enforce test-driven development discipline. AI writes specs first, then tests, captures runtime traces when tests fail, and iterates until green. The LLMs.py project released v3 with access to over 530 models from 24 providers through models.dev integration, adding MCP server connections, Python function calling, and desktop automation capabilities. For those building agentic systems, Rivet's Sandbox Agent SDK provides a unified API for orchestrating Claude Code, Codex, OpenCode, and AMP in containerized environments, with adapters handling translation between universal API calls and agent-specific interfaces. AI security and safety concerns. Running local AI agents with broad system access is starting to feel like the early days of browser security. Everyone's experimenting, few are thinking defensively. A local LLaMA community member shared a cautionary tale after discovering sketchy code in MCP server tool definitions that could have exfiltrated data. The damage was avoided only because the testing environment was sandboxed, but the incident prompted a security practice overhaul. Reviewing tool definitions before installing MCP servers, running agents in isolated Docker containers, using separate AI sandbox user accounts, and maintaining domain block lists for agent network access. The community response surfaced a concerning cultural norm. One commenter noted that curl github.com/shit-h sudo bash has become the default installation pattern, reflecting broader complacency about code provenance. The discussion touched on cordum.io, which attempts semantic governance, preventing agents from executing destructive operations like drop database users or send email, tease all. based on understanding what the code means, not just isolating the runtime environment. This represents a meaningful distinction. Docker prevents agents from destroying the host machine, but has no awareness of whether the code inside is performing harmful business logic. The offensive security community is already building MCP infrastructure for their own purposes. Fuzzing Labs released an MCP security hub providing Dockerized servers for tools like Nmap, Ghidra, Nuclei, SQLmap, and Hashcat, essentially enabling AI assistants to conduct security assessments through natural language. The tools span reconnaissance, web security, binary analysis, cloud security, secrets detection, and Active Directory enumeration. While intended for legitimate security work, the same infrastructure could obviously be misused, highlighting the dual-use nature of agent capabilities. Cisco's AI security team published a detailed analysis of Moltbot, formerly Claudebot, the viral open-source personal AI agent, characterizing it as a security nightmare. The agent's popularity stems from running locally and executing actions on behalf of users, but this same architecture creates significant attack surface. Cisco Foundation AI is responding by building agentic security systems with tools like MCP Scanner to ensure trust and accountability in agent ecosystems, a recognition that agent security requires fundamentally different approaches than traditional application security. The JavaScript ecosystem is facing its own crisis, with 6 zero-day vulnerabilities discovered across NPM, PNPM, VLT, and Bun that bypass script execution and lock file integrity protections. Dubbed PackageGate, the vulnerabilities enable attackers to regain install-time code execution even in hardened environments. 3 package managers patched the flaws, but NPM, now owned by Microsoft, stated it works as expected. This is particularly concerning given the widespread adoption of these defenses after the Shai-Hulud attack that affected over 25,000 repositories. Security researchers warn that PackageGate could enable worse supply chain events because it exploits the package managers themselves rather than just malicious packages. Meanwhile, AI-generated contributions are overwhelming open-source project maintainers. Both curl and LLVM announced new limits on handling AI-generated code. Daniel Stenberg, curl's lead maintainer, is shutting down the project's bug bounty system entirely to remove incentives for submitting poorly researched reports. The goal isn't to ban AI assistants. It's to stop the flood of low-quality submissions from people using AI to cash in on bounties without doing proper vulnerability research. The professionalization of open source is colliding with the democratization of code generation, and maintainers are caught in the middle. AI model evaluation and benchmarking. A local Llama community member built Sanity Harness, an agent-agnostic evaluation tool, and tested it against 49 different coding agent and model combinations. The design philosophy prioritizes understanding over memorization. Tasks measure comprehension rather than training data regurgitation, with 26 challenges across 6 programming languages. Each challenge is intentionally single file to keep evaluation fast, deterministic, and consistent across multiple runs, though future versions may add full project setup testing. The results reveal meaningful differences between agents. Juni scores among the highest performers due to deep integration with JetBrains language server tooling, though users report it's slow, expensive, and has an awkward UI. AMP, Anthropic's agent, stands out as the fastest, with impressive task completion efficiency. The author maintains complete transparency, offering to share all run data for anyone wanting to improve their models or verify the evaluation's validity. The leaderboard at sanityboard.lr7.dev includes run dates, agent version numbers, full reports, and an MCP column for future testing with MCP tools enabled. The question of whether system prompts actually improve coding performance generated a thoughtful discussion with conflicting research evidence. A 2024 paper suggests they don't help with local models, and newer research indicates the same pattern. The community consensus leans toward providing constraints on behavior rather than instilling identity. "You are a senior back-end engineer" appears to be useless, while giving contextual information about goals, stack, and background. Several commenters noted that 2 years ago system prompts mattered more, but current models are trained for these use cases already. The practical advice: tell the model truthfully what's happening, what occurred after its training cutoff, and why you're doing what you're doing. XBOW's founder posted a pointed warning about benchmark gaming. Commercial and open-source security products are comparing themselves against XBOW's year-old published results, which is meaningless. The benchmark was created specifically to validate whether XBOW could find vulnerabilities in never-before-seen code, so models couldn't have been trained on it. Now that the code has been public for a year, that validation is worthless. XBOW stopped using the benchmark internally almost a year ago and has improved significantly since then. The broader lesson: internal benchmarks are the only useful way to evaluate security-focused AI systems, and public benchmarks become contaminated by training data almost immediately. AI-powered development transformation. The concept of the superstack developer, someone whose capabilities span hardware, firmware, intelligence, and continuously adapting systems, is moving from aspiration to reality. One practitioner describes the breakthrough as a shift toward incremental learning with a focus on integrity in complex systems. Instead of collapsing every possible question into a global solution, answer one thing, learn the optimal path, encode it cleanly, and move forward. This produces systems that are understandable, optimized, and grounded, closer to 1970s computer science than modern AI in its constraints and intentionality. The practical scope is remarkable. Atomic-level chip simulations, agentic chips at fabrication, firmware, WASM, Rust, swarms, medical reasoning tools, DNA analysis pipelines, legal systems tracing intent and precedent, and edge systems like Wi-Fi-based DensePose that see through walls by treating signal behavior as a living system. Over 150,000 active users ran swarm systems in production in the last 30 days alone. The bottleneck has shifted from complexity to clarity. Thinking clearly, building deliberately, and encoding what works is now sufficient. Barry Hurd's analysis of 29,252 AI skills across the Claude skill framework reveals structural patterns in what makes agentic team members effective. First-party skills from vendors like Vercel or Expo see a 96x adoption advantage over community skills because they represent production-hardened truth. The most successful independent creators aren't building generic marketing bots. They're building specific workflow suites like SEO audit, copywriting, and programmatic SEO that execute defined steps rather than just chat. The top 10% of skills share structural DNA. 92% use clear instructional scaffolding, and 74% use priority rankings distinguishing critical from optional. The industry is moving from prompt engineering to skill architecture. Steve Yegi's framework for predicting software survival in the AI era centers on a selection argument. Inference costs tokens, which cost energy, which cost money. In any environment with constrained resources, entities using resources efficiently outcompete those that don't. His survival ratio is savings, usage, human coefficient, awareness cost plus friction cost. Software survives if it saves cognition, measured as token spend. Early victims include Stack Overflow, Chegg, Tier 1 customer support, low-code platforms, and content generation tools. IDE vendors are sweating over Claude code. The trajectory continues exponentially. Medium-scale SaaS will be achievable by year-end, and business departments are already vibe coding their own solutions rather than renewing niche vendor contracts. Capability transfer between models is becoming more systematic. A Hugging Face team got Claude to teach open models how to write CUDA kernels, then evaluated whether the transferred skills actually helped. The process: get a powerful model to solve a hard problem, convert that into a reusable agent skill, transfer it to cheaper or local models, and measure the impact. Some open models saw 45% accuracy improvements on kernel writing, but the skill didn't help every model equally. Some even degraded performance or consumed far more tokens. The tool Upskill automates skill generation and evaluation. The variance in results suggests we're watching capability transfer happen at the level where model architecture meets skill representation, which is more nuanced than make model better. AI licensing and open source challenges. Claude Code automatically adds co-authored by attribution to Git commits, and this default behavior is raising fundamental questions about authorship, ownership, and licensing. Ralph D. Miller's LinkedIn analysis which he notes with acknowledged irony was itself written by Claude, examines the legal implications after his new open-source project accumulated 7 contributors in 3 days, all of them AI systems. The legal framework is more complex than it appears, varying significantly by jurisdiction. German copyright law, Urheberrecht, requires a persönliche geistige Schöpfung, a personal intellectual creation, and the U.S. Copyright Office has similarly ruled that AI-generated content without sufficient human creative input cannot be copyrighted. AI cannot hold copyright, be granted patents, or enter into licensing agreements because AI is not a legal person. If the human's prompting doesn't constitute sufficient creative input, just write me a function that does X, then arguably no copyright exists at all. The result, AI-generated code may be public domain by default. This creates a fundamental paradox for open-source licensing. Every open-source license, MIT, GPL, Apache, BSD, assumes a copyright holder exists and grants permissions from that position. If the code is public domain, the license has nothing to attach to. More problematically, licensing requires a contractual party capable of making agreements and bearing responsibility. AI cannot fulfill this role. When an AI-generated contribution introduces a bug or security vulnerability, who is liable? The AI that wrote it, the company that trained it, the human who prompted it? Current legal frameworks have no clear answer. The practical implications extend beyond abstract legal theory. If significant portions of a codebase are AI-generated, and therefore potentially public domain, the entire licensing structure becomes uncertain. Projects may need to develop new contribution guidelines, attribution standards, and liability frameworks. Anthropic's decision to enable co-authorship claims by default without explicit user consent has effectively pushed this problem into every project using Claude Code. The industry is conducting a massive, uncontrolled experiment in AI authorship, and the legal system hasn't caught up. GPU infrastructure and compute resources. The GPU rental market continues fragmenting, with informal providers attempting to undercut established platforms significantly. One Reddit post advertises RTX 4090s at 15-hour, A100SXM at 60-hour, and H100s at 120-hour, roughly 40% of market rates. The community response was immediately skeptical, with multiple users flagging the offering as a likely scam. The provider claims to offer test rigs before payment and explains having access to GPUs at almost negligible prices, but the absence of a proper website and the DM-based transaction model raised red flags. This pattern reflects broader dynamics in GPU compute access. Demand for inference and fine-tuning capacity continues outpacing supply, creating opportunities for arbitrage and for fraud. Legitimate providers like RunPod, Vast.ai, and Lambda Labs have established trust through transparent pricing, SLA guarantees, and proper infrastructure. Informal offerings may occasionally represent genuine excess capacity, but the risk-reward calculation strongly favors established platforms for serious workloads. The compute access problem remains unsolved for many practitioners, particularly those needing H100 class hardware for reasonable durations. AI-driven automation tools. RalphX from Umputun addresses a genuine pain point. Claude Code is powerful but inherently interactive, requiring continuous supervision for complex features spanning multiple tasks. The tool orchestrates Claude Code to execute implementation plans autonomously, running in the terminal from a Git repository root with no IDE plugins or cloud services required. Users write a plan with tasks and validation commands, start RalphX, and can walk away. The key insight is that each task runs in a fresh Claude Code session with minimal context, keeping the model sharp throughout. As context fills during long sessions, quality degrades and the model starts making mistakes. The execution pipeline is sophisticated. Phase 1 reads the plan, sends each task to Claude Code, runs validation commands, tests linters, marks checkboxes done, and commits changes. Phase 2 launches 5 review agents via Claude Code task tool covering quality, implementation correctness, test coverage, simplification opportunities, and documentation needs. Phase 3 optionally runs Codex GPT 5.2 for independent external review, iterating until no open issues remain. Phase 4 runs a second code review pass. Additional features include interactive plan creation through dialogue with Claude, a web dashboard for browser-based real-time monitoring, and automatic Git branch creation from plan file names. In more specialized territory, Razonia's invoice processor handles Vietnam e-invoices with a hybrid extraction approach supporting XML, PDF, and image-based documents. The cost optimization strategy is instructive. Direct XML parsing first, then template matching with regex extraction for PDFs, OCR plus LLM for structured extraction when templates fail, and pure LLM vision for scanned images as a final fallback. The system supports TCT, VNPT, MISA, Viatel, and FPT invoice formats with signature verification against Vietnam CA trust stores. This represents the mature pattern for document processing. Start cheap, escalate to expensive methods only when necessary.